We bootstrapped this company all the way. We just raised our first capital about 6 months ago, which for a tangibles company is pretty difficult to do. But as you saw in the pictures, we were pretty used to eating ramen noodles and peanut butter and jelly. So with this new financing, it allowed us to expand our team. We hired an army of interns to start. We now have over 38 employees, all full-time. But interns at that point in time don't know what people normally make in the real world, so they were willing to work for a pretty small salary. And it allowed us to move into our first warehouse. And when we moved into this warehouse, it was strictly that, just a large, open warehouse. But we had big dreams to start manufacturing in just a year. Pretty aggressive timeline to take a technology that was at the lab bench, had never been created before, and to scale it up and start delivering product. Because Eben, my business partner, he was great at drumming up business, but now we really had to start producing it. With that startup mentality in mind, as well as the bootstrapping model, we built our own laboratories. We had enough space now to start producing the tissue culture that we needed to produce the volumes of product that our customers wanted. Since the technology had never been manufactured at scale before, we started looking at analogous industries, things like agriculture and horticulture, food handling and processing, things of that nature. We bought off-the-shelf equipment and retrofitted it to meet our needs. And of course, we had to build some of our own equipment as well, but we had a great engineering team. And that leads us to mid-2010, and this is when we started producing product. At first, we were only manufacturing about 30,000 protective packaging units, things like corner blocks and end caps like this piece that I have in my hand today, for companies like Steelcase or Dell, automotive components, things like for Ford. But this was sufficient to know that we had our technology, we were proving the marketplace, we were selling a product at cost parity to foam, and it was performing better than the synthetic alternatives. And of course, what was really important to us is that we were displacing synthetic foams. The materials that we're producing today would ensure that more foam plastics weren't being produced, and that we were no longer diverting these high-energy materials into landfills. Now today, if you go into one of our manufacturing facilities, we're currently setting up our second facility in Latham, New York, you'll see that we have walls and walls of growing parts. Basically, we have growing inventory, 5 days of growing inventory, which is then dried at the end of its growth cycle and then shipped out. Today, we grow about 100,000 protective package units a month, and we're currently looking at expanding further into Texas to quadruple that size even further and to continue to address new customer needs. Now, with these technologies, we received quite a few accolades. For those of you who do not subscribe to Packaging World magazine, we were on the cover of it this month. It's because we won the DuPont Sustainable Packaging Award. This is the most prestigious packaging award that you can receive, and we won the Diamond category, which is the highest ranking that you can achieve. We were also honored this year by being recognized by the World Economic Forum as a technology pioneer for 2011. And all of these really support us and help us to continue to grow and to address new market opportunities. Because you see, we're not done yet. Protective packaging is only one market. There's only one place where foams are used today. We're focused on addressing other market segments, including construction materials. We're looking at structural insulating panels. Our material has comparable insulation characteristics to an open cell expanded foam, but it's also a Class 1 firewall, something that you can't get out of a foam today. And what's really interesting is that if you look at some of these prefabricated structures, the glues are a pretty expensive part of the cost. And we can actually grow our materials, since we literally grow a glue or grow an adhesive, directly into wood veneers or oriented strand board for everything from work surfaces to walls within a construction site. We're also looking at automotive applications. Things such as synthetic composites are fairly ubiquitous. Since we grow a resin, we can bind natural particles and fibers together, things such as hemp or jute fiber, and make a natural alternative to synthetic composites. Our materials, not only are they inexpensive, but they're also really healthy, since all of our technologies don't emit the volatile organic compounds or the formaldehydes that are associated with engineered woods and synthetics. So with that, I really need to thank our supporters. We did bootstrap this company, and it was a pretty difficult feat, but we raised over $4 million in the last 4 years through grants and awards. Agencies such as the U.S. Environmental Protection Agency and the National Science Foundation were really instrumental through the Small Business Innovation Research Program in terms of helping us scale up our technology from the lab bench to an industrial scale. Furthermore, we still have a great relationship with the United States Department of Agriculture. They're starting to identify different biofuel wastes, things from cellulosic ethanol and the like, that we can start to use in our product to make those technologies more economically viable, since now we're taking their wastes and giving them additional value. And to briefly summarize why we use mycelium today, first, we use open loop feedstock system. We can get our raw materials from anywhere, anything that has lignin or cellulose in it, basically. Our materials literally self-assemble in the dark at room temperature, very low embodied energy. We like to say that we have 100% biological efficiency because everything we put into the tool, we get out of the tool, with the exception of some respiratory gases that are produced. We're not feeding a microbe a really high-value starch, for example, and getting out a very small amount of product. And finally, we're working with Mother Nature's plastics. This is a material that nature herself invented millennia ago, and now we're just reallocating it to a new industrial process. With that, say thanks.